Today we're going to unfold this part with LS-Prepost 4.3.35. So the first thing we need to do is extract middle surface because this is a solid surface. To do that, we go to surface and down here middle surface, and we're going to create middle surface by solid. So the solid surface is represented by the old displayed surface. So we select all active entities. And then right here, the program going to analyze the surface. Looking at the lower right corner, you can see mid-surface average gap is 1.92. So that must be the thickness of the part. Double click here, you can expand this message window and see the information more clear. Alright, then right here it says post action. We can say no action, or we say hide the solid, only see the middle surface. So I select that, then apply. Now we can see the middle surface created, and there are some extra surface here, which is probably coming from the original surface. We can turn them all off, so only display those. I am going to leave some of the dirty surface here so I can show you how to clean them on the mesh level. So I'm going to leave some surface here, close. Then the next step is mesh. We go to MF Pre or the mesh. Both will go to the same function, which is auto mesh. And the auto mesh, we need to use the size mesh. One step, you always use the size mesh. The mesh size, the smaller the better, the smaller the slower. We'll just use the default. And then we select all the surface, active displayed surface, and then mesh. Once it's meshed, we're going to turn off the surface. All the surface is off. So except the only thing displayed here are all the meshes. And we can see there's some missing area and some gaps. We can clean them up by go to this called element editing. Element editing. Right here you can show the free edge, and we can see there's some edges here, right here. And then we can just delete it. We go delete, and then we can delete by you select area, multiple point, or just pick. We just pick that and delete them. And we can go out, take a look. And we can see all these looks good, and this doesn't look very very normal. There must be some surface there and brought some mesh here. We're going to delete that by pick, and there are more than one, so I'm going to go use a propagate and then angle. What it does is when you pick one element, the program will continue look for the connecting element within this angle. So we got all of them here. And delete, accept, done. Now we can take a look. It looks clean now. So all these open missing area, we have other function to patch it up. Next thing is we need to check normal. We go to normal here. When you select normal, and you will see the color change, which means the negative normal direction will change to different color. The positive normal direction will stay the same. Our part was red, so the normal is pointing inward. If you like to see the actual normal, you can just say, okay, select all the active element, display, show the normal. You can see the normal all showing inward. And we can reverse them. Go reverse, and then say reverse. So it's reverse all the elements in your buffer, which is here, the 7508, all of them reversed. Okay, reversed, done. Then we can go to application, metal forming, one step forming sim, and pick the part to unfold, and we can fill up all these patched area. So we go fill up, and then all the mesh will be created in the opening area. Then we pick the material. We'll just pick a material here, and the thickness, we know the thickness is 1.92, and then these are the new options in this newer version. You can define the boundary constraint. You can define them by thinking if you need to put a draw bead there or not when you form the part. If some part you need to have a draw bead, putting on boundary constraint will give you a more closer estimation of the unfolded part. 3 reference nodes, you don't have to pick them. If you don't pick them, it goes to the XY plane default. If you pick them, it will based on the 3 nodes you define, the plane defined by the 3 nodes that you picked. And you will have a file called reposition.k something. Then we can give a file name. I'm going to just give any name. And then say save keyword. You can save the project also. And then you say run. When you say run, the program will send the file, output file into LS-Prepost. And you have to hit this play to start the calculation. This calculation will take a couple minutes, and when this is running, I'm going to show you some other things that is good to know. Normal. The normal, if I select normal here, most case we can just flip the whole thing and done with it. But sometimes you have normal point to different directions. Then you need to use another function. I'm going to create this situation by say reverse normal of this group. Okay, so we have normal pointing up here and pointing down here. So let's say I need to align them. Align them, you select align, and then you have 2 options. One is align toward some point, some coordinate. Let's see, 0.0. Let's say 10,000, 100,000. Some this means there's 1 point above you. Above you probably reach the ceiling. All the normal is pointing to that coordinate, that point, and that's toward. Toward is not always usable, and you can imagine for this part you will have they point up, and then all the bottom part pointing up too. So we use align. Align by using a seed element. A seed element. When you use this function, you need, when you select seed element, make sure this buffer is 0 first. I'll tell you why. Because when you select seed element and you pick one seed element, and let's see we like everything normal toward normal consistent with this group. So I pick one, and then this element is in the buffer. So what it does is it's going to look for all the elements next to this element and then flip them like this. So you, after picking them, go to auto reverse. Program will continue propagate from this element throughout the part. If your buffer have a lot of elements here, program will think that's all your seed element. Then program will keep looking for the element near those elements which in the buffer. And that if you pick too many of them, like you pick all the elements as a seed element, program will keep searching, keep flip, and then that will take a long time. You might think the program stuck, but actually it's just the way this program. So that's one thing about normal by seed element. And the seed element you picked will list it here. Actually, you can type it in. Okay, the simulation is finished. So we can go to result and say open. This will bring the result. Look at lower left corner here. Here. If we didn't do the reposition, the program will bring in the result from D3plot file. This is what it means. If you reposition them, there will be a keyword file called reposition.key. Okay, so this did bring in from the D3plot file. You can output the blank line by a IGS file by click on that and give the file name. You can see the blank thickness contour, and you can reverse the contour, and you can also go thinning, plastic strain. And for FLD, you do need to bring in the current thickness and the material information, or bring in the the file for the FLD curve, which is this curve. So that will give you a more accurate evaluation for the forming limit diagram. And that's all for the new one-step program. Thank you.